Have you ever pondered about the intricacies and enigma of quantum physics? If so, you're not alone. It's a field that's both fascinating and challenging, a realm where the rules of traditional physics are turned on their head and where the impossible becomes possible. Quantum physics, in essence, is the study of the smallest particles in the universe, the very building blocks of everything we see around us. It's a field that's as bizarre as it is beautiful, filled with phenomena that defy common sense, and yet are fundamental to our understanding of the universe. In this video, we'll embark on a journey into the heart of quantum physics. We'll break down its complex concepts into easy-to-understand segments and share insights that will help you grasp this awe-inspiring field. From the basic principles to the mind-bending concepts of superposition and entanglement, we've got a lot to cover. Prepare to unravel the mysteries of quantum physics as we delve into it step by step. To decode quantum physics, we must first understand its fundamental concepts. The world of quantum physics is truly fascinating, and it begins with three core ideas: wave-particle duality, quantum superposition, and quantum entanglement. First, let's talk about wave-particle duality. This concept tells us that every particle, like an electron or a photon, also behaves like a wave. It's like being at the beach, where you can feel the grains of sand beneath your feet, but also experience the rhythmic motion of the waves. In the quantum world, particles can behave as both particles and waves depending on how we observe them. Next, we delve into quantum superposition. Imagine you have a coin. When you flip it, it's either heads or tails, right? But what if, in another universe, that coin could be both heads and tails at the same time? That's essentially quantum superposition. A quantum particle can exist in multiple states at once until it's observed. Once observed, it collapses into one state. It's a bit like Schrödinger's famous cat, both alive and dead, until you take a peek. Lastly, we have quantum entanglement. This is where things get really interesting. Two particles can become entangled, meaning their states are directly connected, no matter how far apart they are. If we change the state of one particle, the state of the other changes instantly. This is what Einstein famously called spooky action at a distance. To sum it up, wave-particle duality tells us that particles can behave like waves. Quantum superposition tells us that particles can be in many states at once, until observed. And quantum entanglement tells us that particles can be intertwined, their states instantly affecting one another, no matter the distance between them. With these fundamental concepts, we have laid the groundwork for understanding quantum physics. Now let's dive deeper into the world of quantum, where things get even more exciting. Imagine being in two places at once. Sounds impossible, right? Welcome to the concept of quantum superposition. Now let's dive into this mind-bending concept that forms a cornerstone of quantum physics. Quantum superposition, in a nutshell, is the ability of a particle to exist in all its theoretically possible states at once, until it's observed or measured. Yes, you heard it right. It's as if you could be both sitting and standing at the same time, until someone turns to look at you. Picture a coin. The moment before it lands, it's neither heads nor tails, but a superposition of both states. This state of uncertainty, of being both heads and tails at once, that's the essence of quantum superposition. It's not that we don't know what state it's in, it's that it truly is in both states at once. But here's where it gets even more fascinating. Once we observe the coin, once it lands and we see whether it's heads or tails, that superposition collapses. The coin is forced to choose a state. This is what we call the observer effect. You might be thinking, how is this even possible? Well, in the world of quantum physics, the rules of the game are entirely different. Traditional physics, the kind we experience every day, simply doesn't apply here. Let's take Schrödinger's cat, a famous thought experiment. Imagine a cat, a flask of poison, and a radioactive source all sealed in a box. If an internal monitor detects radioactivity, the flask is shattered, releasing the poison and killing the cat. Quantum superposition suggests that until we open the box, the cat is both alive and dead. It's only when we observe the cat that it becomes either alive or dead. Intriguing, isn't it? This concept, as surreal as it may seem, is what allows quantum computers to process vast amounts of data simultaneously, promising a revolution in the world of technology. Quantum superposition, a concept that defies our everyday logic, is a key pillar of quantum physics. Quantum entanglement, a phenomenon so bizarre that even Einstein called it spooky action at a distance. So what's this spooky action all about? To put it simply, quantum entanglement happens when a pair or group of particles interact in ways such that the quantum state of each particle cannot be described independently of the state of the others. Imagine you have a pair of gloves, one left-hand glove and one right-hand glove. You put each glove in a box and send them to opposite ends of the universe. Now, without opening your box, you know that if your box has the left-hand glove, the other box, no matter how far away, must contain the right-hand glove. This is a crude analogy, but it helps us grasp the concept of quantum entanglement. But in the quantum world, things get even stranger. Before you open your box, the glove inside is both a right-hand glove and a left-hand glove at the same time. It's only when you open the box and observe the glove that it becomes either right or left. And the moment you observe your glove, the glove in the box at the other end of the universe instantly becomes its opposite. This is quantum entanglement, where the act of observing one particle instantly affects its entangled partner, no matter the distance. Now, you might be thinking, how can this be? How can information travel faster than light? Well, that's exactly why Einstein found it spooky. But numerous experiments have confirmed that quantum entanglement is real, even though it defies our everyday intuition. In the real world, quantum entanglement has potential applications in areas like quantum computing and cryptography. For example, entangled particles could be used to create a communication network that is impossible to eavesdrop on. Quantum entanglement, though counterintuitive, is a fundamental aspect of quantum physics that continues to baffle and fascinate us. Do you think quantum physics is just theoretical? Think again, it plays a significant role in our daily lives. Now you might be wondering how. Well, let's start with the device you're using right now to watch this video. If it's a smartphone, a computer, or a tablet, it's all thanks to the principles of quantum physics. These devices are powered by tiny electronic components called transistors. And guess what? These transistors work on the principles of quantum mechanics, specifically the concept of quantum tunneling. But it doesn't stop there. Have you ever had an MRI scan? This medical imaging technique uses the principles of quantum physics to capture detailed images of the body's internal structures. The superposition property of quantum physics allows the MRI machine to differentiate between different types of tissues in the body, providing doctors with valuable information. And what about the world of computing? Quantum computing, a field still in its infancy, promises to revolutionize the way we process information. Quantum computers use the principles of superposition and entanglement to perform complex calculations at speeds that are unimaginable with today's computers. While it's still early days, the potential applications in fields like cryptography, data analysis, and artificial intelligence are simply mind-blowing. Even our understanding of the sun and stars wouldn't be possible without quantum physics. The sun, for instance, shines because of nuclear fusion, a process that is governed by the principles of quantum mechanics. Without understanding quantum physics, we wouldn't be able to comprehend how stars work, much less harness the power of nuclear fusion on Earth. In the end, quantum physics, though it might seem abstract and complex, is not just confined to textbooks. It's woven into the very fabric of our daily lives, from the technology we use to the medical treatments we rely on, to our understanding of the universe itself. Quantum physics, though complex, is not just confined to textbooks. It is very much a part of our everyday life. Embarking on an exploration of quantum physics may seem daunting, but hopefully, this video has shed some light on its fascinating concepts. We dived into the deep end, breaking down this complex field into digestible segments. Remember, we began with the basic concepts, illustrating the peculiar nature of particles that behave both as waves and particles. Then, we unveiled the concept of quantum superposition, a phenomenon where particles exist in multiple states simultaneously until observed. The exploration continued with quantum entanglement, where two particles become inextricably linked, mirroring each other's state, no matter the distance between them. Lastly, we brought quantum physics right into your living room, showing you its role in our daily lives, from the technology in your smartphone to the future of computing. Next time you come across a complex concept like quantum physics, remember, with a bit of patience and curiosity, even the most complicated topics can be decoded.